What I'm in a constant process of doing is evaluating, Janelle, what things you're excelling at, where our weaknesses are, and attacking our weaknesses. Making sure that our weaknesses become strengths. When that happens, we're in really good position. Lena, I think it's time to take some worksheets out. No, I know that. Look at how high that stack is.
Oh, yeah, I know.
Yeah, it's
Well,
time.
I didn't choose to take all these.
I know. It's your mean math teacher. That's a lot of work. You know what? You know what kids say to me all the time? They go, you know, when we come to class, we feel like we never do anything, and then we look at the stack of notes and worksheets, and we're like, oh. Kids tell me that all the time. Now, so I mentioned the other day how two things that I'm taking out of your quizzes and work lately are some struggles with radicals and some struggle, and the radicals are getting better, and some struggles with this concept of range. Now, what variable is range? Y. So it says, what is the range of this function? The range of the function will be whatever y values are part of the graph. So to find the y values, I draw the graph. You guys with me on this here? I draw the graph over to the y-axis, and I want to see what values this corresponds to. Now, first off, I look at the choices, and choices 1 and 2 are ridiculous. Why are choices, Sarah, you head in the game. Why are choices 1 and 2 ridiculous?
Because they represent the x.
That's right. That's domain. Range is y. So 1 and 2 are out. If you had 1 or 2 as a choice on your quiz, where did you blow it? What? Where did you blow it if you put choice 1 or 2?
You put the x value.
You put the x value. That's nice. If it would have said, what's the domain? Oh! I do like to change questions a little bit for tomorrow. So, theoretically, that's a direction I could go in. Ow. Now, so in this problem, 1 and 2 are out because they're x's instead of y's. Y's are range. So now, as I look at choices 3 and 4, which one most accurately or most closely matches up to the parts of the y-axis that are covered here? What parts? I would say 0.97 to 2.38. Clearly, it's not 1.27 because that's around here, and there's part of the graph below that, so that can't do. So it has to be choice 3. Okay? What variable represents range? Y. And if I want to find the range, I draw over to the y-axis. If I want to draw domain, what would I draw there? Down to the x-axis. Good. All right, next up. Given this, which value of k will make this not a function? Now, I chalk this up, if you missed it, to it having been a long time since we did functions, because this is a very simple question. All of my regular 8th graders who answer this kind of question on every single homework, kind of like you guys do equations on every homework, they would all nail this question. It says, which one makes it not a function? It's not a function when the initial domain or x value repeats, because every input, that is x value, is only allowed to have a unique output. You're not allowed more than one input for an output. So 8, 3, 7. Choice 3 is 3. That would make it 3, 6, and 3, 4. That's not allowed. Okay? Therefore, choice 3 is the one that would make it not a function. And for this one, again, as far as what is it isn't a function, it fails the vertical line test. It touches here and here, touches twice on a vertical line. That is not a function. Anthony.
Also, number 4 is also on like number 3. Number 4 sides are open. Well,
That's exactly right. Yeah, they're trying to trick you on that. The big difference between choices 3 and 4, in choices 4, the circles are open. So if you draw the vertical line, you don't exactly equal it on that point. Kim, are we okay there?
Yeah.
You sure? I can't see you. No, I can't. I cannot. You're camouflaged. I have this buddy of mine I fished with for many years by the name of John Haig. John Haig was a mountain of a man. He was every bit of 6'6", 280 pounds, but he wore 280 like a normal guy would wear 210. He was just so powerfully built. He played Division I college football as a linebacker, and he was on ABC's Wide World of Sports for surfing. And he was a very tough-looking man, and big, strong, monstrous. He was actually, the first year that they made drunk driving a crime, they made a poster that they put out of a guy in a jail cell with a cop locking him up, and John was the cop locking him up. It said, "Meet your new bartender." He was a motorcycle cop, a very, very, very strong, tough human being. So John one day was fishing in the river, and there was all of this water in the whole river that anybody could have fished. And he's standing there fishing, and he has camouflage waders on. And this guy comes in the river and stands about 10 feet away from him. So John looks over his shoulder and goes, "Man, these must be really, really, really good waders." And the guy goes, "Okay." He goes, "Yeah, because if you would have seen me, you never would have stood that close to me." You don't get that, do you? Well, you don't want a crowd. You got all of this room, and he's got to stand right next to him. You can't, like, give him a little space to let him go do his fishing in? Kim, you don't fly fish, do you? No, we have to get you into fly fishing.
Wait, what does that have to do with Kim being frustrated?
It's her camouflage jacket. I can't see her, and you couldn't see Haig.
What a tangent. Wow. That was impressive.
Yes, I
That's like
am.
better than me in Spanish.
Very good. Spencer, anytime my tangents come close to your tangents, I consider that to be apocalyptic. Okay, now, let's take a look at the homework from last night very quickly. I didn't answer all of the questions like I usually do. I only went through 2 short sections. I wanted to make sure that you're able to interpret some data off of this graph. Now, Spencer left first, because Spencer left first at what they're counting as time 0, which is the time that McKenna leaves.
Oh, wait.
Spencer's already got a head start. Okay?
We're talking about Spencer.
No, not that Spencer.
Not Spencer.
Okay. About how long till they intersect? I guess it's about 3¼ hours, looking at the numbers on the chart there. McKenna's speeding up because her slope is increasing. McKenna is an exponential function. You can tell just by looking at it. You know, again, that sight recognition thing. As far as Spencer goes, I'm not 100% sure what they're looking for on the Spencer answer. Personally, I think it looks most like a square root curve. All right? But if you wanted to argue linear, I could kind of see that. It's not linear in the beginning, but it kind of tapers to linear. So I could hear that. A great way to find out the actual equations are with regressions. Remember we showed you yesterday how to enter the data in L1 and L2, and then go to stat calc. And then if it's an exponential, you do an exponential regression. If it's linear, you do a linear regression. All right? The y-intercept is the distance they are at the time when when McKenna leaves. So Spencer is 20 further along. Okay? Assuming that these numbers on the bottom are hours, which I don't see listed anywhere, assuming they're hours, then Spencer is increasing faster because his slope is greater. So that would be my guess as far as that goes. And over here, I did this off the top of my head. I hope I came out with the numbers right. I think I did. I did not use a calculator at all. And when you start talking about fractions with denominators of 320, it gets a little bit complicated. All right? But there's the completing the square one. Any questions? Still half and square, even though it's an ugly fraction. Okay? Half of 3/4 is 3/8. That gives me 9/64. Add it to both sides, and a fifth of 9/64 I think is 109 over 320. Everything else is very straightforward. And the formula is down here. Okay, Hannah came in this morning very expressing her frustration that she's having a hard time with it, and she nailed it, except she left off a sub 1. Don't forget a sub 1 yet. The whole idea behind recursive formula is this. I'm going to tell you what the first one is, and then I'm going to tell you the rule for going from one to another to another to another. So if I tell you the first one and then I tell you the rule, you know where you start, you just apply the rule. So I start at 1, I multiply by -4. I start at -2, I go down 3. Okay? Any questions? All righty. Today's lesson sheet. Time to get rocking. Okay, so we need to be able to recognize graphs like we just went over the exponential graph before. We know the parabola or the quadratic graph. We also need to be able to recognize data in tables. And we're slowly drifting the way we do things over to including, we're slowly drifting over to including data sets now, not just graphs, not just function rules. So if I look at this one, what is this going up by? 6 every time. So what kind of data would this be? If you go up by the same amount every single time?
Linear.
Linear, good. It's also, if I expressed it as a sequence, it would be arithmetic, because it's going up the same amount every time. What about this one?
Quadratic.
It is quadratic. How could you tell it's quadratic?
Because it goes up, then goes back down.
That's a good way to look at it. And also notice, these two match up with the 2. Now, I know I don't have the number underneath here, but the 24 would match up with it in terms of its distance from 32. It would also be 24, I'm sorry. All right, so that would be quadratic. And what's this one? AJ?
Exponential.
How do you know it's exponential?
It's like it's going up by a fast amount and like
By a what?
it's going up very fast. So like it's
That's a good way to, that's a strong hint. But there's a way to absolutely certify and stamp that it's exponential. Janelle?
I don't think I'm right, but I see it goes from 3 to 9, so wouldn't that be like?
Multiplying by 3. That's the big thing. Exponential has a common ratio. 81 divided by 27 is 3, divided by 9 is 3, divided by 3 is 3, divided by 3 is 1. Okay, so there's a common ratio there, and this is geometric, because it's being multiplied each and every time. Okay? Any questions on those? All right, so the big thing, that's the first time I've shown you the data as a table, and what you were supposed to be able to do on that was take a look at it and say, oh, I recognize the kind of data that is, okay? All right, and obviously the parabola or the quadratic in the middle is neither geometric or linear, or arithmetic or anything else. All right, so let's take a look at what we have here. Noam and Athena had an argument about whether it would be longer to get to New York City, from New York City to Boston and back by car or by train. So their differences, they made separate non-stop round trips from New York City over to Boston. This is, by the way, is about where I'm gonna retire to, right around here. So, not that way, over here. All right. Now, on the trip, at the end of each hour, both recorded the number of miles they traveled from their starting points, blah, blah, blah. First table shows Noam. Second table shows, who's the other person? Athena. All right, so, now remember, this is the distance from New York City. They're going to Boston and they are going back. All right, so take a look at, this is like a lame question, but we'll go through it. It's good for analyzing purposes. Take a look at the two tables and see what you think. Noam is in blue and Athena is in kind of rose or puce or whatever that not very manly color is.
Wow. Oh my god.
I did say not very manly.
I just spelled train, T-R-A-N-E.
Ah. I once forgot how to spell the on a test.
God.
Just Mr. Lindquist. All right. So, how would you describe a function rule that would explain Noam's distance? How would you describe that? Go ahead.
What, like in y equals mx plus 3 are the ones that we've been doing so far?
Well, more general, quadratic, exponential, linear.
Quadratic.
I don't think so.
X linear.
X linear.
Linear. It's linear.
What is X linear?
It's like linear, except I messed up and I stuttered.
Thought you were going to say it was like the X Games. Okay. Now, yes, this is an X linear function. What am I going up by here?
55.
55. All the time, turn around and come back with 55. Now let's take a look at Athena's distance. What would you describe Athena's function as? Come on, head of the game. What would we describe this as? AJ?
Quadratic.
It is quadratic because the numbers are symmetric around here, but if you notice, it's not always up and down by the same amount. Here's 9, here's 27, 45, I guess that is, and so on and so forth. So you can see, God bless, that there is a little bit of a change going on. So this guy here would be quadratic, and this guy here would be x linear. Okay. Who do you think's driving? Anthony.
Oh, I was just reaching.
Oh. Who do you think's driving? Somebody who hasn't helped me yet. Come on. Will it make you feel any better if I tell you that I don't think there's a right answer? I don't think there's a wrong answer. I think it's more about how you defend your answer. Miss Pappas, who do you think is driving, Noam or Athena, and why?
Oh, no.
I wanna say, I think Athena,
Why?
because it's taking a longer time.
Okay, you think that driving would take longer, okay.
I can't really
That's not exactly the best defense I've ever heard. Spencer,
I would like to disagree
okay,
because assuming that the distance is in miles.
Yes.
Which is an assumption. Okay. So she's moving 81 miles in 1 hour. It's 81 miles an hour
yes,
at any given point in time. Like
Well, for the first
an
hour.
average, for an average. She's moving at 81 miles an hour.
yes,
Which is not impossible with a car, but it's most likely illegal wherever you're driving.
I do it all the time,
That's really,
My
that's
dad
really
does
not.
that.
constantly.
But he's driving at 55 miles an hour, which trains don't usually go at. Also, she's moving at like a non-constant rate, which means that while they were making the stops, that's probably where the rate was coming from.
Possibly, but,
Because the average.
and this is why I think there's not an answer. I get everything you're saying, it's all completely
it's only
logical.
81 miles an hour
However,
test.
however, think about this for a minute. How many trains stop at 1 hour, at 2 hour, at 3 hour, at 4 hour? Wouldn't it normally cover long distances where there's no towns? And then it tends to get congested and it's like a stop, a stop, a stop, a stop. So I think that's part of it. And the other thing is this, I want you to tell the truth. Your parents cannot see you right now,
Yeah,
okay?
yeah.
No, they can't. Just don't say anything if you don't want them to hear your answer. Whose
Aren't you
parents
recording
really
this?
truly drive 55?
No.
My dad.
Wait, no, never mind.
I never really.
My mom.
We have
does.
one.
Aren't you
My mom
recording
does,
this?
'cause-
Truth.
Oh, my dad.
We have 2, maybe 3 people in the whole room that drive 55. Who drive more like me?
My dad.
My dad.
That's it, we put that pedal down and go, baby, go! Okay. My car goes very, very fast. I like going very, very fast in my car. I don't think twice about hitting 100 miles an hour. But it has to be in certain places at certain times. Yes?
Why doesn't it show like stopping?
Oh, then Kaylee wants to tell me why she's gonna be a fast driver. Go ahead. I want my Aussie to keep up. Go ahead.
If it were to be like a train, wouldn't it stop? Like, why doesn't it show that?
Right. And that's why ultimately, Kaylee, I don't think there's a good answer. Remember how I said I don't think there's a really good answer? I think if you went with Spencer's route and said, look, the speed limit's 55 miles an hour, this person's doing 55, I think that was their gist behind why they put that table there. However, I also don't think it's realistic, because if you're driving, if you have ever driven on open highway, by open highway I mean like say north of New York City, or this is I-95 between New York and Boston, there's long stretches where there aren't too many towns, and you can get up and fly on that road. In fact, the speed limit on that road is 65 miles an hour. And everybody in the universe knows the cops give you 10 miles an hour. Everybody knows that. Your father was a cop. He knows it. 10 miles an hour at least. On the expressway, I constantly set my cruise control at 70 miles an hour and have cops go right by me. And they never pull me over. Do not do this when you first learn how to drive. You are not ready for this. Only after you gain experience and you have a car that's running really, really good and is made to go fast, which I have and you don't, then you can do it. But when you are a young driver, you don't do that. Are you perfectly clear on that?
Yeah.
Okay. Yeah, it's very important, because I don't want to read about you dying. Now, okay. So that's why I think that this is somewhat unrealistic. But by the same token, also as you get closer and closer to Boston, you're going to slow down, because there's more and more traffic. But by the same token, if you go over here, you're getting that slowing down effect closer and closer to the area. So this could be more like driving. But then again, trains don't go 55 miles an hour. At least most trains don't. Yes?
But they're all constant, so I can infer that no one took the train, so, because it's always constant.
Yes, I agree, except there tend not to be equal stops in between them. So, first off, I really appreciate the use of the term infer rather than imply, which means you're very educated. But I don't think there's necessarily a right answer. I think it's more in the defense of it. Okay, next up, according to the data, how far apart are Boston and New York City? There are two answers that are very close to each other. Egan, how far apart are they?
Like 225.
Or 220, right, depending on which table you're looking at. I guess the train station's a little further away than the actual house. Okay. How long did it take for each of them to make the round trip? How long for Noam?
8.
8 hours, good. How long for Athena? 10, very nice. All right, according to their collected data, which method of travel was faster?
We don't know.
Well, Noam's. That much we could say, whatever Noam did. Noam believes that a quadratic function can be used to model both sets. Can we use a quadratic for both?
No.
No. Why can't we use a quadratic for the first one?
Because
Going
it
up by
doesn't-
constant.
It's a constant, right, exactly. It's not variable like a quadratic would
Why did
be.
you skip B?
Did I skip B? I did B. I did A, I did B. I did C. I did D. Oh, E. What was the average rate of change for Athena from the interval from 3 to 4 hours? Average rate of change. What does rate of change mean, guys?
Y
Slope. Same thing, right? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Says 3 to 4 hours. So that would be 216 minus 189 over 4 minus 3. That would be 27 over 1, which is the average rate of change is 27 miles per hour. Good? Does anybody think this is hard?
Nope.
Yeah?
Yeah, because I got confused on why, what's x linear, and I didn't understand.
X linear is a joke. You do get that, right?
But you wrote x linear, that's why.
Yes, I did.
because
I
knew
did.
it
I was
different.
making fun of Spencer.
Oh,
It's linear.
oh.
Okay? Yes, if you heard Spencer, when I asked Spencer what this was, he started to say exponential.
Me too.
He started to say exponential. He went X linear.
Kristen knows how to write bullet reports. She just did 3 of them.
Did she?
Yeah.
Add one for AJ. Okay,
No,
next.
actually for Mr. Duran.
For Mr. Durant.
Does Mr. Duran live on 22 Carey Street?
I don't know.
Say
I know
though.
my sister's name is Carrie. And we did know thing. All right, I think we've got, listen, hey. What you should be able to do today, hey, stop. You should be able to look at a table and tell, is it linear, constant rate of change? Is it exponential, constant ratio? Is it quadratic? You've got that down and up and variable factor.
Yeah. Or.
Sure. Hey, if you're okay, guys, relearn packets. I only had, I think, 2 or 3 people here, 2 people today. All right, we got to get those done. There is absolutely no wiggle room. I don't want people coming up to me at lunch on the 30th saying, "Oh, can you look at my packet?" No. If you haven't been doing it all along, the answer is no. I'm not going to look at your packet. Got it? Boy, oh boy, my mom used to say, I'm talking to the wall. I think I'd be talking to the wall.